Hello dear learners, welcome to our channel Concept Corner. In this video I am going to solve question number 5a of exercise 3.3. This question is very easy. You have proved this type of questions in general mathematics. Also in some previous exercise also we have done this type of maths, no? So the question is that square of every integer can be expressed as 3k or 3k plus 1, where k is some integer. So for this type of question we have to use division algorithm. So first of all we have to consider any integer. So very easy, let's see. Let a be any integer and b is equal to 3. Why I am considering b is equal to 3? Because we have to prove it in the form of 3k or 3k plus 1. So I have taken b as 3, no? So using division algorithm, what we get a is equal to bq plus r, no? Where r is less than b or greater than equal to 0. Here the value of b is 3, so put it a is equal to b means 3q plus r. Here b means 3, put it 3, here r, and less greater than equal to what? 0, no? So therefore what are the possible values of r? So possible values of r are 0, 1 and 2, no? So when r is equal to 0, then a will be, or you can write directly, therefore values of a will be, if we put r is equal to 0, then a will be what? 3q plus 0, that is 3q. If we put r is equal to 1, then 3q plus 1, and if we put 2, then 3q plus 2, no? These are the three possible values of a. So we have to prove that square of every integer. So we got these three integer. Now we have to show that square of this integer can be expressed as either 3k or 3k plus 1, these two type, no? So let's see first integer. Now 3q square means what? 9q square, no? And 9q square can be written as 3 into 3q square, no? And this can be written as 3 into this term 3q square is written as k, where k is equal to 3q square. So one first digit is proved as 3k, so we can say that square of this integer is expressed as 3k. So let's say second integer is 3q plus 1 whole square. So it is a plus b whole square. A plus b whole square means it will be 9q square plus 6q plus 1, no? A plus b whole square, you know it very well. So in this case we can't prove it as 3k directly because 3 is not common from all the terms. So from these two terms we can take 3 common, no? Why I am taking only 3 common? Because we need only 3, no? So I am taking 3 common. So here 3q square will remain and plus 2q, no? And this plus is extra, no? And this can be written as 3 into this thing is taken as k, and this one is plus 1, where k means k is equal to 3q square plus 2q, no, 3q square plus 2q. So 2 number is also proved. Second integer, let's say third integer, 3q plus 2 square. 3q plus 2 square means 9q square plus 12q plus 8. So here see, we need to prove either it can be written as 3k or 3k plus 1, no? Oh sorry, it will be 4. So since we need either 3k or 3k plus 1, in this case we can't say 3k because nothing is common in all the 3 terms. But if we write like that, 9q square plus 12q, this 4 can be written as 3 plus 1. Then from these 3 terms we can take 3 common and plus 1 will remain extra. So here 3 common, 3q square, 4q plus 1, and this plus 1 is extra. So 3 into this term is taken as k and this plus 1, where k is 3q square plus 4q plus 1, no? Therefore we can write, therefore square of every integer can be expressed as 3k or 3k plus 1. Very easy, no? So we will see next question. Next question is also you can do in the same way. So I am proceeding to the next question. So I am doing 6 number 1 question. 5 number 2 question you can do yourself, very easy. 5 number 2 question is also present in your general mathematics, no? So same question, so I am not doing here. So let's say question number 6 on for any integer a, show that 2 divides, this is division sign, this is read as 2 divides a into a plus 1 and 3 divides a into twice a square plus 7, no? So there are 2 sums actually, this is one sum and this is one sum, where a is any integer, no? So a is any integer. Let's see, let us consider solution. Let a be, this a be any integer and b is equal to 2. First of all we are going to prove this part, no? There are 2 sums. So using division algorithm, if we use division algorithm, we get a is equal to bq plus r, where r is less than b, greater than equal to 0, no? So a is equal to b means 2q plus r, where r is less than 2, greater than equal to 0. Therefore what are the possible values of r? R will be equal to 0 or 1, because b is 2, so r values of r will be 0 and 1, no? Let's see, therefore a will be, what will be the value of a? If we put 0 we get 2q plus 0, that means 2q, and if we put 1 then 2q plus 1, no? Very easy. So now we have to prove for a equal to twice q. For every integer we have to prove that a divides a plus 1. 2 divides a into a plus 1. So for the first integer we have to prove that 2 divides a into a plus 1, no? So let's see for a equal to twice q, we have a into a plus 1. So let's see, is it dividing by 2 or not? A means what? 2q, no? And a plus 1 means 2q plus 1, no? So this thing 2, this thing if we write as k, no, then 2 into k, 2 into something means what? That means we can write 2q in this bracket also, 2q plus 1, no? That means 2 is multiplying with some integer, this is some integer, or you can write it 2k, where k means this thing, q into 2q plus 1, no? So k is some integer and it belongs to z, no? This thing belongs to z. So now see, a into a plus 1 is equal to 2 into some integer. That means what? Therefore 2 divides a into a plus 1, 2 divides a into a plus 1. So for the first integer it is true. So let's see for second integer. For a equal to 2q plus 1, no? For 2q plus 1, a into a plus 1 is equal to, a means what? 2q plus 1, 2q plus 1, and into here a means what? 2q plus 1 and plus 1. Now see, here 2q plus 1 and here 2q plus 2. So 2q plus 1, here 2 is common, so we can write 2 into q plus 1, no? So now see, these 2 if we write here, and these things 2q plus 1 into q plus 1, no? Again if we take this thing, since 2q1 all are integers, so this whole thing is an integer, so we can write 2 into, suppose, k1, where k1 is equal to 2q plus 1 or q plus 1, no? k1 is equal to 2q plus 1 or q plus 1. So what can we write? Since a into a plus 1 is equal to 2 into something, some integer, so we can write therefore 2 divide a into a plus 1. So in the same way you will do the next part of this sum, very easy. So in the last sentence what will you write? For any integer we can show that for any integer a, for any integer a, we can show that 2 divide a into a plus 1, very easy. So in this same way you will do the next part of this sum. So for today this much. Thank you. Let's see question number 3 of question 6. This question is that if a be any odd integer, prove that 24 divides a into a square minus 1. This time a is any odd integer, not any integer. In the previous sum it was given that a be any integer, but in this case a is odd integer. So we have to proceed in the same way. Let a be, first of all we will consider any integer, a be any integer and b is equal to, this time 24 is there, so 24. So using division algorithm we can write a is equal to bq plus r, where r is less than b, greater than equal to 0. Now we have b means 24, so 24q plus r, where r is less than 24, greater than equal to 0. No, now see, since this is very long value of b, so possible values of r will be, therefore r is 0, 1, 2, 3. In this way we will get up to 23, no? 1 less than the value of b. So the values of r a will be equal to, if we put 0, 24q plus 0, 24q. If we put 1, 20, 24q, 24q plus 1, 24q plus 2, 24q plus 3. In this way we will get up to 24q plus 23. Now as we need odd integers, so we have to consider this time odd. So here odd integers are here, odd integers are odd integers are, which are odd integer? 24q plus 1, 24q plus 3, no? In this way up to 24q plus 23, no? So by considering this integer, we have to prove that 24 divides this term, a into a square minus 1. So first of all, see, for a is equal to 24q plus 1. So for a is equal to 24q plus 1, no? 24q plus 1, we need to find a into a square minus 1. So right, a means what? 24q minus 1 into 24, oh sorry, plus 1. 20, a means 24q plus 1 and a square, that means 24q plus 1 square, then plus 1, no? So let's see, we need a 24 here, no? 24 into something. If we can show multiple of 24, then we can say that 24 divides this term. So 24q plus 1, it remains same. Here if we break it, no need to multiply it. 24q square means what? 24 into 24 and q square, and if we multiply it, 2 into twice ab, that means 2 into 24q into 1, no need to write 1, then 1 square, 1, and then plus 1, no? So now see, 24q plus 1, from this thing, sorry, minus 1 is there, so minus 1, this is minus 1. Now see, from this value, 24 into 24q square plus this plus 1 and minus 1 will get cancelled, so here it will remain 2 into 24 is into q, no? So from this two term, 24q plus 1, here 24 is common from the both the term, so 24 taken out, and here 24 q square remains, and here 2q remains, no? So 24 is multiplying here, no? So we can write 24 in front of the sum, and 24q plus 1, and here 24 q square plus 2q, no? Since we express it in the form of multiples of 24, so 24 can be taken this side, that means therefore 24 divides a into a square minus 1, no? Very easy. So for the value 24q plus 3, we will show it. say 4 to a is equal to 4 a equal to 24 q plus 3, no? Let's see, a into a square minus 1 is a means what? 24 q plus 3, and here 24 q plus 3 whole square and minus 1. Here see, from these two terms we can take 3 common. Here remains 8q plus 1, no? And here if we multiply it, we can write 24 into 24 and q square. No need to multiply. How will multiply this big number? No need to multiply, no? Plus 2ab. 2ab means what? 2 into 24 into 3. 24 into 3, and q remains q, and then plus b square. B square means 3 square. 3 square means 9, and minus 1. Now see, this 3 remains 3q plus 1, and here remains 24 into 24 q square. It can be written as 2 into 24 q, and here 8, no? So 3 remains same, 3q plus 1. From this whole term 8 is common. If you see, from here, here, from the all 3 terms 8 is common, so we can take out 8. Here remains, from 24 8 comes out, so 3 into 24 q square. From here 8 comes out, so it remains 2 remains same. From 24 8 comes out, so 3q, and from here 8 comes out, so 1. Now see, 3 into 8 24 into this thing 3q plus 1, and this thing 3 into 24 q square plus 6q plus 1, no? So I will not multiply this thing. You may multiply yourself, no problem. So now see, again 20 multiples of 24. 24 into some integer. This is nothing but some integer. So 24 divide a into a square minus 1. Therefore 24 divide m into a square minus 1. So we can't show for all the values. So by showing for 2 values, we have to write like that. Therefore for a equal 24 q plus 5, 24 q plus 7, the remaining odd numbers, that means, and up to 24 q plus 23, we can show that 24 divides a into a square minus 1. So that's it. So we can show that for any odd integer. One more line you have to write. Therefore for any odd integer a 24 divides a into a square minus 1, no? That's it. So very easy sum. So the next video will be very important. This type of sum usually don't come, but the sums which are going to be proved or solved in the next video are very important. So that video will be very important for you and important. So those questions will come in exam. Always those questions comes in exam. So don't miss the next video.